Hi, my name is Gabriel Rueda, and this is my Lab 4 presentation for Physics 1. So this lab is exploring the experimental and modeled motion of a mass on a spring from a video in the lab instructions, and the modeling is done on GlowScript, and the experimental data is taken from a video that is put through Tracker and modeled as a point mass system. The model is compared to the experimental data by the tracker data being put in a CSV file and then directly put into the GlowScript model and compared with a chart. So in the rest of the slideshow, that will show the data compared to each other. The lab uses key formulas for kinetic, potential energy, and spring energy, which is potential energy. Gravitational energy is another potential energy. Uses key relationships between these different values, these values of velocity, position, energy, and their relationships to each other. The tracker data, which is shown here, the video was put into Tracker, and the position of the object was measured at each frame, and the data was then taken by Tracker and put into a table. The video was called Spring Mass 2D, and it took about 94 values for the position over the course of 94 frames. And then what I did was I took the X and Y positions individually, put them into a CSV file, removed the time values, and save that CSV value or CSV file, which could then be put directly into the GlowScript model. And so this GlowScript model used both the model data, which was taken from the experimental data in the initial values, meaning the initial position, which is written here, and the initial speed, which was taken from the difference between the initial values over the time, and it was scaled approximately to have delta t as 0.005 seconds. And the mass of the ball was described in the beginning of another one of the videos to be 0.402, and the length of the spring was roughly 4. The spring constant was 6.8. So as you can see from this previous slide, the modeled and experimental data were very similar. And the reason for that was because in the video itself, there weren't any significant forces outside of the spring and gravitational forces that were acting on the mass. And it was a relatively simple system with a relatively ideal spring. And so that's why the data sets were very similar. In the X and Y directions, the oscillations were not the exact same. The period of the oscillations weren't the exact same, and that's why they have different sized waves here and here. It's because their period is different, as will be explained in the last slide. And the kinetic energy is primarily taken from the Y direction, as it's moving more in the Y direction than in the X direction. And the potential energy is entirely in the Y direction. There's no change in energy for the system as a whole, because the kinetic energy is purely due to the potential energy, and the potential energies cancel each other out. and there's no work or heat done on the system, so you can know from that there is no energy, like net energy. So in conclusion, these models are made with surprising accuracy because of how ideal the situation is. The X position period was roughly 1.1 and the Y position was 1. The energy principle is satisfied.